Hi Year 12, this is the third lesson for our topic sequences and series. In this lesson we'll look at arithmetic series. So far we've covered what sequences and series are. We've looked at sigma notation, arithmetic sequences, and how to find the nth term of an arithmetic sequence. So recall that a series is the sum of certain terms in a sequence, and we can write S subscript 5 to mean the sum of the first 5 terms, T1 plus T2 plus T3 plus T4 plus T5. And we can also use sigma notation, and this means exactly the same thing. This is the sum of the first 5 terms. Now let's have a look at the sum of n terms in an arithmetic series. So we're going to consider this arithmetic series here. A is the first term. Here's the second term. It is A plus the common difference. Here's the third term, A plus 2 lots of the common difference. Now let's skip to the end. I'm letting L be the last term or the nth term. Now this term here would be the last term take away a common difference. And this one is L take away 2D. Now to sum this, we're going to use Gauss's method. Remember how he added the numbers from 1 to 100? So let's have a look here. The first and the last term, that adds to A plus L. The second and the second last term is equal to A plus D plus L minus D, which is equal to A plus L. And the third and the third last term, this is A plus 2D plus L minus 2D, which is equal to A plus L. And all of them are going to add to the same thing. And altogether, there will be n divided by 2 pairs. So there's our formula. Sn is equal to n over 2 multiplied by A plus L. Now, it's not a particularly useful formula because often we don't know the last term. The last term is actually the nth term. This is the sum to n terms. So I can substitute in the formula that we learnt last lesson in for L, like this, and tidying it up, I get another version of the sum to n terms. And this one is n over 2, and then in brackets 2a plus n minus 1d. Here's example 1. Find the sum of the first 15 terms of the series 7 plus 11 plus 15 plus 19. Okay, we're going to start by figuring out what A is and what D is. Now A is 7, and 7 plus 4 is 11, so D is 4. And N is going to be 15. Now let's substitute into the formula. We're going to get S subscript 15 is equal to 15 over 2, and then in brackets 2 times 7, that's the first term, and I've done a little bit of a shortcut here. Instead of putting in brackets 15 minus 1, I've done that in my head and written it as 14. Straight into the calculator, and we get 525. Example 2, find the sum of the series 1 plus 3 plus 5 all the way to 31. So it looks like we're going to use that other formula, n over 2 in brackets A plus L, because we know what A is, it's 1, and L is 31. But we don't know how many terms there are. So what we're going to have to do is use this formula and figure out which position this is in the series. So Tn is going to equal 31. So let's substitute in A is equal to 1 and D is equal to 2. Let's take this 1 over the other side, and I'm going to expand through these brackets at the same time. Add 2 to both sides, 2n is equal to 32, so n is equal to 16. There are 16 terms. Now we can use the formula. So S16 will equal 16 over 2, and then in brackets 1 plus 31. And into the calculator, we get 256. Example 3. Find the number of terms in the series 2 plus 4 plus 6 if the sum is 420. So again, let's figure this out. A is 2, D is 2, and we don't know n. Into the formula. This time Sn is going to be 420. So 420 is equal to n over 2, 2 times 2, plus n minus 1, and d is 2. Okay, let's tidy that up. We get 4 plus 2n take away 2, which is equal to 2n plus 2. Now expanding through these brackets, this is n on 2 times 2n, that's n squared, plus n on 2 times 2, that's n. And making a quadratic, I have n squared plus n take away 420 is equal to 0. Now we can factorise this, but if you don't feel confident factorising that, use the quadratic formula. But we get n minus 20, n plus 21, and so n could equal 20 or negative 21. But n is the number of terms, it has to be positive, and so there are 20 terms. Example 4. Find the sum of the terms from n equals 5 up to 25 of 3n plus 1. Okay, a little bit tricky because we're not starting at 1 here. What we're going to do is substitute in, I'm going to substitute in n equals 5 and then 6 and then 7 and generate this series. So putting 5 in, I get 3 5s are 15 plus 1 is 16. Now let's put 6 in. 3 6s are 18 plus 1 is 19. And put 7 in, we get 21 plus 1 is 22. I'm going to skip all the way to the end and put 25 in. So 3 25s, so 75 plus 1 is 76. So there's our series. Now I'm going to call this the first term. The common difference is 3, and we just need to figure out which term this is in this new series. So if this is the first, which was at n equals 5, and this is the last at n equals 25, there's actually 21 terms. Now it's a bit tricky. Most people would think it's just going to be 25 take away 5, but in that case we haven't included n equals 5. Okay, so it's inclusive of n equals 5 and n equals 25. So we go 25 take away 5 and then add on 1. So there are 21 terms. You might have to think about that for a little bit. Now we can do it in the formula. So S of n is equal to n over 2 and then a plus l because we know the last term. So the sum of 21 terms is 21 divided by 2 and then in brackets 16 plus 76, which is 966. Now there is another way to do this question, and this is a really useful technique to know as well. So instead of putting in n equals 5, then 6 and 7 and generating a brand new series, we can do this. So this is saying that the sum from n equals 5 to 25 is the same as the sum of the first 25 terms, so from n equals 1, take away the sum of the first 4 terms. Can you see how that works? We still need to generate the series, but this time I've put in n equals 1 and 2 and 3. And using our formula, sum of the first 25 terms is 1,000, the sum of the first 4 terms is 34, and subtracting, we get the same answer. And part 3, J only has 200 tiles. How many complete rows of the pattern can J make? So again, we're going to use the sum formula, and the total sum is 200. We don't know n. We know that A is equal to 3, so this is 2 times 3, and here's D. Okay, let's tidy this up. This is 6 plus 2n take 2. And further simplifying, we get that. Now let's expand through these brackets. N on 2 times 2n is n squared, plus n on 2 times 4 is 2n. And tidying it up into a quadratic. Now, the previous question that I did with you on this, we were able to factorise, but I suspect from this sentence here that there's going to be tiles left over, so we won't be able to factorise. We'll get a decimal. So let's put it into the quadratic formula. N is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 200 all over 2 times 1. And we want the positive square root because we don't want negative tiles. So n will equal 13.2. And so J can make 13 complete rows. Now let's finish off with simultaneous equations because we can get these sorts of questions involving the sum formula. And this is actually a past HSC question. In an arithmetic series, the fifth term is 200 and the sum of the first 4 terms is 1200. Find the value of the 10th term. So we've got 2 pieces of information here. The 5th term is 200. That's going to form our first equation. A plus n minus 1d, so that'll be 4d, will equal 200. And then we also know that the sum of the first 4 terms is 1200, so we're going to use the sum formula for this. Sum of 4 terms is 4 over 2. 2a plus n minus 1d is equal to 1200. Let's tidy this up. So 4 divided by 2 is 2. Divide both sides by 2. Now have a look at these 2 equations. We're going to have to multiply this one by 2 so that we can eliminate. So that gives us 2a plus 8d is equal to 400. And bringing this one up, 2a plus 3d is equal to 600. Let's subtract. 2a take away 2a is 0. 8d take away 3d is 5d. And 400 take away 600 is negative 200. Divide both sides by 5. D is equal to negative 40. Now let's substitute back into here. So we've got A plus 4 times D is equal to 200. So that's A take away 160 is equal to 200. And taking that 160 over the other side, we get A is equal to 360. But have we actually answered the question? It says find the value of the 10th term. So now let's substitute back into the nth term formula. So a plus n minus 1d, so 360 plus n minus 1 times d, and our 10th term is actually 0. Okay, that's it for arithmetic sequences and series. In our next lesson, we're going to look at geometric sequences.